welcome to Cherry Pie Math. This video is going to introduce what probability is and give you some examples of probability in real life. So before we get started, we are going to be using fractions. Let me write this down. Fractions, decimals, and percentages. Because this is how we are going to represent probability. So we're going to have some examples here. So like 3/5, if I was to convert that to a fraction, you might remember from earlier in earlier lessons, but you do the top divided by the bottom. So in this case, it would be 3 divided by 5, which comes out to 0.6, or 60%. Converting from a decimal to a percentage, you just go whoop whoop, and then if there's an empty space, you put a 0. If you have a decimal, it's easy to change it into a percentage. You just go, again, you bring it over 2 spaces, whoop whoop, and you get 25%. Going back is a little bit harder. The easiest thing that I find is you take whatever this is and then you put it over 1, and then the amount of digits is the amount of zeros that you have. So in this case, it would be over 100. 25 over 100 is going to be 1/4 if you divide them both by 25. Kind of same thing. So if you have a percentage and you're going to try to get the fraction and the decimal out of it, instead of going whoop whoop, you're going to go whoop whoop this way, and you get 0.3. And then same idea, if you want to find what the fraction is, you put it over 1, and then the amount of digits is the amount of zeros. So in this case, it's just another 0, and that would be 3/10, because you can't simplify that anymore. And there you go. That is how you would convert very quickly from fractions to percentages and back. I do have a video that I will link that goes over more in depth about how to be able to convert between those. Okay, so let's say someone tells you that if you pick a random person at school, there's an 8% chance that that person is a teacher. So I want you to think about what that means. What does that 8% mean? Or what is that chance? So when you were thinking about it, you probably thought about, okay, that means that there's not a lot of teachers compared to the rest of the school. And if you think about percentages are out of 100, right? An 8% chance means that 8 out of 100 is, or 8% proportion, I guess, would mean that 8 out of 100 people would be teachers. And so a chance would be that for every 100 people you pick, 8 of them are probably going to be teachers. So probability is the likelihood of an event happening. So like, for example, in the teachers, the 8% of the school was teachers. It was the likelihood that you would select a teacher. The probability of selecting a teacher was 8%. So we represent probabilities in fractions, decimals, and percentages, just like I was showing you earlier, just because these are the way we would represent ratios. This is a mathematical way of having ratios without having like out of written down. We don't want to use extra letters if we don't have to. So these are the 3 ways we represent probabilities. I would say, honestly, like all of these I've seen used. I've used all of them, and I've seen all of them for each student that I've taught. Like, it depending on the question. The easiest thing to make is probably a fraction, because that's the first thing you make, because you want to be able to write down that ratio. But then when we're interpreting what that probability means, it's easier to see that out of 100, which makes it more of a decimal percentage thing. So I guess that's kind of what I'm trying to say, is that fractions are kind of how you would write them down, like organize your information. But that's typically not how we would write down the probability at the end. We would put these so that we could see it out of 100. Out of 100%. So all of them have a place. Decimals and percentages are basically the same thing. You just put the dot in a different spot. Okay, so let's think of some examples. So some examples of probability, maybe you can like roll a dice. Just think about like random things. So like, I don't know, flipping a coin. You might also think of maybe the weather. You see some like, there's an 80% chance of rain today. The weather's actually an interesting one. I'm not going to go into it in this video, but the weather is a questionable one. Anyway, but for the purposes of this video, it's an example of probability because you're saying there's a likelihood. We're looking at the likelihood that it's going to rain. So some non-examples of probability is when there's not really that random element. It's not really like, that it's not really representative of an entire population. So if I have a percentage, it's not really reflective of the population. So some non-examples of probability is like voluntary sampling, where the only people that respond to, like, if you're trying to find the probability of something, then the only people that respond are like really old people. That's not really representing the entire population, right? Or we also have like something called convenience sampling, which is what it sounds like. So like, imagine you're trying to get data and you just ask like the first 20 people to exit the library. That's not really representative of the population. So it's not really a great example of probability, just selecting someone that comes out of the library, because it's not really representing the population. There does need to be some element of randomness to it. So let's calculate the following. So rolling a 4 on a 6-sided dice. One thing that I've noticed is people be like, oh, this is a number, I should put that on the top. Please don't. Remember that 4 is just one side of a 6-sided dice. So I'm going to put 1 out of 6 because this is my number of successes out of my total possibilities. And that's kind of how you find them. You do successes. Did I spell that right? Yeah. That you do successes over possibilities. So drawing a spade on a standard deck. Just so you know, a standard deck has 52 cards. And of those, there are 4 suits. So if you wanted to count, every single spade in the deck, you'd get, let's see, what would it be? 13, right? So you'd have 13 over 52. Or you could think, oh, there's 4 decks. That's just 1 in 4. So that would be my number of successes over my number of possibilities. In a fraction, you do need to simplify it as much as you can. So this would actually be marked incorrect. It would have to be 1/4. But then if you changed it into a decimal or a percentage, you're just going to be safe. That would be 25% or 0.25. Flipping a coin and getting heads. There are 2 sides and one of them is heads. So that would be my probability. Or if I was to make it into a percentage, it would be 50%. So each of these describe what is called a success. A success in probability is what you're looking for. It doesn't always have to be good. A success in math is just what you're looking for. So like, let's say that I want to go to get Asian food for dinner and my husband wants to get Mexican food for dinner. And we flip a coin, the chance of, and I want to calculate the probability of getting Mexican food. That's not a success for me, right? It would just be a success for him. So in math though, a success, and it's so weird because math takes the English words and then it's like, hey, let's make a different definition for it, or like a really specific one. But a success in probability is what you're looking for. Just keep that in mind. A success in probability is what you're looking for. So let's talk about what happens. Can you get more than 1 for a probability? So if I'm trying to pick something randomly, is there more than 1 chance? And one way to think about this is 1 as a decimal is just 100% in probability. Is it possible to get more than 100% chance? No. 100% means absolutely. And so you can't get more than 100%, right? And the same idea, can you get less than 0 or 0%? No, this means it will never happen. So kind of same thing, no, you can't have negative possibility. Negative possibility. So that is the limit. All probabilities have to be, if you're doing like decimal or fraction, it has to be, I'm going to do P in between, P for probability. It has to be between 0 and 1. If it's a percentage, actually I can just do this for percentage. It would be 0 and 100%. Same idea. The probability has to be between 0 and 1 because otherwise it doesn't make sense. You can't have it happen more than guaranteed, and you can't have it happen less than never. It has to be between 0 and 1. So what does it mean to have a probability of 40% then? If something says that there's a probability of 40% that it'll happen, what that would mean is, remember, this is out of 100, right? Percentages, decimals, even fractions, when you think about it on the scale that we're thinking of, is between 0 and 1. It's between 0 and 100. So that means out of 100 trials, or out of 100 data points, or whatever you're looking at, roughly 40 of them, I guess, will be a success. That's essentially what it's saying. So let's say like the probability of getting a red candy. And this is a notation, by the way, and I'll talk more about that in another video. The P represents the probability, and then in parentheses you write down the success that you want to happen. So if I know that that the probability of getting a red is 40%, that means that out of 100, 40 are red. But it also means that I can adjust it. So like, let's say I'm actually just looking at 25. 25 is 1/4 of that. So if I was to multiply 40 by 1/4, I don't know why that did that. If I was to multiply 40 by 1/4, I would have 10. You have to keep the ratio the same. You have to keep that percentage the same. But that's basically what it means. It basically means that no matter what you do, the ratio will be 40 to 100, or whatever the percentage is to 100. So some things to remember: probability can be represented as a fraction, decimal, or a percentage, but it has to be between 0 and 1 or 100%. Successes are over total possibilities. Whenever you're calculating a probability, it's just whatever you want to happen over the total amount of options, I guess there are. And then percentages are really nice because they tell us out of 100 trials, and our brains are hardwired to think about it in terms of 10, at least in the English language. And in this modern society, we think in terms of 10, we think in terms of 100. So having those percentages helps us understand in terms of 100. Okay, I hope that helps, and good luck.